You run an experiment and see a difference. But is it real or just random luck? Hypothesis testing is the disciplined way to answer that, and the famous and famously misunderstood p-value is its verdict. Every honest data scientist must understand it. We begin, perhaps counterintuitively, with skepticism. We assume the null hypothesis that nothing is going on, the new drug does nothing, the change had no effect. This is our default, our devil's advocate. To claim a real effect, we must gather enough evidence to overturn this assumption of pure chance. Enter the p-value. It answers one precise question: if nothing were really going on, how likely is it that we would see a result this extreme just by luck? A large p-value means this could easily be chance, nothing to see. A tiny p-value means pure luck would almost never produce this, something real may be happening. By convention, we pick a threshold beforehand, often 5%. If the p-value falls below it, we call the result statistically significant and reject the null hypothesis. It is a formal way of saying, this is surprising enough under mere chance that we no longer believe it was mere chance, a line in the sand against fooling ourselves. But beware the traps. A p-value is not the probability that your hypothesis is true. Statistical significance does not mean the effect is large or important. And test enough things, and some will look significant by pure accident. The p-value is a useful guardrail, not a proof. Respect for it means knowing its limits. In machine learning, this thinking is everywhere. Is model A genuinely better than model B, or did it just get lucky on the test set? Did that new feature really help? A/B tests, which power decisions across the tech world, are hypothesis tests at heart. Rigor here is what separates a real result from a mirage. So, hypothesis testing. Start by assuming nothing is happening. The p-value asks how likely your result is under that assumption. Small enough and you reject chance, but never mistake significance for proof or for importance. With that, you have the full mathematical toolkit of machine learning. It only remains to see it all fit together.